Today we're going to be talking about simple rational functions. Rational in math means basically a fraction, so rational functions. So let's take a look at an example. Y equals 3 divided by x, any k divided by x, constant divided by x. Okay, these rational functions have a vertical and a horizontal asymptote at x equals 0 for the vertical asymptote, x equals 0, because when you plug in 0, that would make the function undefined. So x cannot be equal to 0. And y also will never equal 0. So y equals 0 is a horizontal asymptote. Now you can plot some points by plugging in some x values, but you'll find if your x value is positive, so is your y value, and if your x value is negative, so is your y value. So we're just going to sketch the branches. It gets really close to the horizontal asymptote. It doesn't curve back in. It approaches the vertical asymptote, and it approaches the horizontal asymptote. So that is a sketch of a basic rational function, like the parent function. If we put a negative in here, well, that's just going to reflect it. That's going to reflect it. So basically, you flip your branches. So for negative, you need to know that the branches are in the second, and again, in the third, approaching the asymptotes, not curving back in. Okay? So if you look at the domain and the range of both of these, let's do domain. Domain of the pink and the blue. It's everything except x equals 0. So the domain, no matter what, is going to be negative infinity to 0 in union with 0 to positive infinity. Whether that's a positive k or a negative k, your domain is going to be all reals except 0. Now look at the range. What y values are not included? Well, again, you have a horizontal asymptote, which means the graph will never reach that. So the range is negative infinity to 0 and 0 to positive infinity. So that's your basic domain and range. Now what if I asked you for x and y intercepts? Well, as you can see, there aren't any x and y intercepts. When you plug in 0 for x, it's undefined. When you plug in 0 for y, that's not possible either. So there aren't any x and y intercepts. Let's take a look at a translated function. Let's do y equals negative 4 over x minus 2 plus 1. Let's talk about translations, h and k. Okay, well, this is x minus your new h value. So it's going to be y equals some constant, x minus your h value plus your k value. And you're going to translate to h, left and right, and then to k, which is up or down. So x minus 2. A lot of people think that means 2 to the left. But what makes your denominator 0 is where the function is undefined. And it's 2 that makes your denominator equal to 0. So your denominator, you can't divide by 0. So you have a vertical asymptote at x equals 2. X minus your vertical asymptote. Okay? Now when I put a plus 1 on the end of all this, I get a y value and I add 1. So where's that going to translate? That's going to translate up 1. So instead of having your horizontal asymptote at y equals 0, you're going to have your horizontal asymptote at y equals 1. So think of this as your new origin. You've got quadrant 1, 2, 3, and 4. Negative k value. Where do you think, sketch where you think the branches would go? Well, in this case, the branch is going to go over here and over here. That's a sketch. Okay? But let's find what these x and y intercepts are, because that could help us with our sketch as well. Okay? So let's go ahead and find an x-intercept. How do you find x-intercepts? Plug in 0 for the y value. Plug in 0 for the y value. And then you need to use your algebra skills to solve for x, which people have a hard time with because there's a fraction here. So to get rid of any, I told you before, to get rid of any rational equation, multiply through. But a lot of people forget to multiply the 1 by the denominator. So what I would recommend is to move that to the other side first, just to be safe. And then we're going to multiply both sides by x minus 2. I'm going to multiply this by x minus 2. So that's going to distribute the negative 1. That's going to be negative x plus 2. And if you want to think of this as over 1, because that's easier for you, these will cancel. These factors cancel, and you're left with negative 4. So 6 equals x. So your x-intercept is 6, 0. Okay, so let's look at that. Over here, 6, 0. We have a sketch, close enough, right? 6, 0. Okay, let's take a look at the y-intercept. Let's see if we can figure out what that is, the y-intercept. The y-intercept is when what is equal to 0? That's when x is equal to 0. So 0 minus 2 plus 1, that's a negative 4 divided by negative 2, which is positive 2 plus 1, which gives you a 3. So you plugged in 0 for x, and you got a 3 back for y. So going back to our graph, that's 0, 3. So we have 6, 0, and 0, 3. So that kind of gives you an idea of where your branches are going to go as well. Okay? Try the domain and the range. Go ahead, and if you want to pause the video, write down the domain and the range. The domain is all reals except 2. Negative infinity to 2, 2 to positive infinity. No brackets. You're not including anything. How about the range? Everything except 1. All y values except 1. Okay? Okay, I'm going to give you an example to try, and I want you to answer all of those questions. So y equals 4 over x plus 2 minus 5. Before you start, think about the translation. I don't want you to do the whole thing wrong if you get the translation wrong. Think about the translation. X minus h. X minus your new x value. What makes the denominator 0? That would be -2. So you cannot have x equals -2 on your graph. That's going to be where your function is undefined. And how about this -5? Where is that going to move us? That's going to move us down 5. So again, y equals is a horizontal line, y equals -5. Always label your horizontal and vertical asymptotes. Okay, so now you can stop the video. This is what I want you to do. I want you to sketch the graph. I want you to label the asymptotes always, which we already did. I already did that for you. I want you to find the x and the y intercepts, if there are any. And I want you to find the domain and the range. That would be number 4, not number 5. Okay, so stop the video and go ahead and try those. Okay, let's check your answer. I'm going to find my x and y intercepts before I sketch. I'm going to do that first. Plug 0 in for y. So to solve that, I'm going to add 5 to both sides. Multiply by x plus 2. (5x plus 10 equals 4). 5x equals -6, so x equals -6/5. So that is a -6 fifths, comma 0. So that's just a little bit over 1. No, let's just say right around there. Okay. And let's do the y-intercept. Plug 0 in for x. And that gives you 4 divided by 2 minus 5, which is -3. And again, you plugged 0 in for x, and you got a -3 for your y. Make sure you write that in the correct order. So if we go back up here, 0, -3, there's our y-intercept. So that means that, does it make sense that it goes through those 2 points? Okay. And if you try to use a graphing calculator, which you should not on these, this is a non-calculator problem, you're only going to see this piece possibly. You need to know that there's 2 branches. And again, our k value is positive. So your branches should be where? Again, think of this as your new center. If k value is positive, it should be over here in the upper right and in the lower left. So we're just doing a sketch. You don't have to plot a whole bunch of points. And there is the graph of the sketch of that rational function. So the last thing I asked you to find was domain and range. So the domain are all the x values. So every x value except -2. That's -∞ up to -2, not including -2. And then the range, all the y values are everything except -5. And that is the interval notation for all reals except -5. And that is all.